Hi dear all, here we are starting with the electronics. Our topic is PN junction. Before going to discuss the PN junction, let's have an overview about the topic. Solid state materials are broadly classified as conductors, insulators and semiconductors based upon its property of carrying charge carriers. Conductors are those which conducts electricity, that means they have a large number of free electrons. In insulators, the free electron concentration is very low and their capacity to conduct electricity is very small, and so they cannot conduct electricity and they are classified as insulators. Whereas there is a group of material which is termed as semiconductors, which have conductivity ranging in between conductors and insulators. That means their conductivity is low as compared to conductors, whereas high as compared to insulators. Here we are going to discuss something about semiconductors. Then about semiconductors. The main commonly used semiconductors are germanium and silicon. The important property of germanium and silicon is that they are tetravalent. Tetravalent means the outer shell contains 4 electrons, 4 valence electrons. This valence electrons is responsible for the majority of the properties. For a stable state, the outermost electron must have 8 electrons. So in order to complete the octet, the semiconductors requires 4 more electrons. Usually semiconductors, the bonding is, the semiconductor crystals are formed by covalent bonds. Covalent bond means sharing, bonds formed by sharing of electrons. In the case of a semiconductor, for a single germanium atom, it has 4 valence electrons. Okay, 1, 2, 3, 4. They need 4 more electrons. So 4 more electrons are given by 4 different germanium atoms, and they will share the electrons to complete the octet. The pattern will be repeating to complete a crystal lattice. That is, this periodic repetition of this germanium atoms will form the germanium crystal. Okay, here a single germanium shares 4 electron with 4 germanium atoms. Okay, one germanium atom will give 1 electron, other will give other electron, other will give other electron, other will give other electron, and this periodicity is repeated and we will get a whole lattice, germanium lattice. So at room temperature, some of the bonds will be broken and there will be electrons and holes. What do we mean by then holes? When a covalent bond breaks, an electron will break out and it will form free electrons. That means this electron can freely move through this lattice. Okay. And there will be one deficiency of electron. This deficiency of electron is termed as a hole. The deficiency of electron have a positive charge and this is termed as holes. In semiconductors, there are 2 charge carriers, free electrons as well as holes. Here what will happen in the case of the holes is that the hole means it is a deficiency of electron. So the deficiency always wants to complete its deficiency. So it will attract other electrons, other free electrons in the lattice, and it will gets filled. So one electron will be attracted and it will complete its octet. Again another electron, the deficiency will be transferred from one portion to other, and likewise this deficiency will be transported, or it will be like a mobilizing valence electron from one portion to another. Actually whole conductivity means it is really the valence electron conduction. This is the basic thing. Then as temperature increases, what happens is that some of the some of the electrons will acquire more energy due to high temperature. As a result, the velocity of the electrons increases, thereby increasing the chances to break the covalent bonds, thereby forming an electron hole pair. So when a bond is broken, one electron is released and electron will be getting free to move through the lattice. As the energy increases, its velocity increases. Again, this electron will acquire high velocity and it will undergo collision. More and more electron hole pairs are created. That means as temperature increases, its conductivity increases. That means its resistance decreases. Decreases means it has a negative coefficient of resistance. Negative coefficient of resistance means as temperature increases, the resistance decreases, and this property is termed as negative coefficient of resistance. Then now we will think about the how we can increase the conductivity of a semiconductor. Conductivity of a semiconductor can be increased by adding some impurities. The process of adding impurity to a semiconductor to increase its conductivity is termed as doping. Then next, what type of impurity can we add? We can add either pentavalent impurity or trivalent impurity. So pentavalent impurity, for example, arsenic and antimony, and trivalent impurity, examples, indium boron. Then pentavalent impurity. Pentavalent impurity means material which has a 5 valence. 5 valency means the outermost orbit contains 5 electrons. When we dope this pentavalent impurity with a semiconductor, already we know that a semiconductor here in germanium or silicon has a 4 valence electron. So they will share the 4 valence electron with the pentavalent electrons. So 4 electrons of the pentavalent atoms of arsenic or antimony, thereby forming octet. But there will be 1 electron free in the pentavalent impurity, and this free electron will be contributing to the conductivity of semiconductor. The impurity added semiconductor is termed as extrinsic semiconductor, and there are 2 types of extrinsic semiconductors. One is N-type semiconductor and the other is P-type semiconductor. N-type semiconductor is obtained by doping it with pentavalent impurity, and P-type semiconductor is obtained by doping it with trivalent impurity such as indium boron. Trivalent impurity means the valence orbit contains 3 electrons. So there will be one deficiency of electron, and that will form the holes. So in semiconductor, holes are also charge carriers. So by doping it with the trivalent impurity, the hole concentration increases, and hence the conduction of current increases by increasing the hole concentration. Hence, in P-type semiconductor, holes are the majority carriers, and in N-type semiconductor, the free electrons are the majority carriers.